Question 1. What internal structure prevents edge breakdown in an avalanche diode? A diffused guard ring structure is engineered around the junction edges to reduce electric field intensity and prevent early edge breakdown. Question 2. The avalanche multiplication process introduces an additional noise metric known as Because the carrier multiplication process is statistical in nature, it introduces an inherent fluctuation known as the excess noise factor. Question 3. In avalanche photodiodes, the ratio of electron-to-hole ionization coefficients is called The ionization rate ratio between holes and electrons is defined as the K factor, which heavily influences overall device noise. Question 4. To minimize noise, what design characteristic is preferred for the ionization K factor? A lower K factor means only one carrier type dominates impact ionization, preventing chaotic runaway feedback noise. Question 5. What happens to the response speed of an avalanche photodiode as the gain is increased? At extremely high gain levels, the avalanche takes longer to build up and decay, which ultimately reduces the device speed. Question 6. Which specialized avalanche photodiode structure separates light absorption from multiplication? Separate absorption and multiplication, or SAM-APDs, isolate the photon capture zone from the high-field multiplication zone to improve performance. Question 7. In a transient voltage suppressor, what does the clamping voltage represent? Clamping voltage specifies the maximum voltage drop across the protection diode when it is handling its rated peak pulse current. Question 8. What property makes silicon avalanche photodiodes highly popular for fiber optic networks? Silicon APDs offer very high quantum efficiency and exceptionally low noise profiles when tracking wavelengths around 850 nanometers. Question 9. A single photon avalanche diode, SPAD, operating under steady reverse bias is called In free-running mode, the device is biased continuously above its breakdown voltage, waiting to be triggered by a single photon at any time. Question 10. What structural defect can cause localized early breakdown in an avalanche diode? Microscopic crystal dislocations or impurities distort the local electric field, creating microplasmas and causing early, uneven breakdown.